All right, this is Coach Lebetter. I'm doing a video on how to do solving linear systems algebraically, but using the elimination method. All right, so I'm going to do these three problems. Now, when we do the elimination method, it's just like if we were making zero pairs. So in my class, we talked about zero pairs. And let's review a little bit about zero pairs. Zero pairs are like when you have two of the same thing, except one's a positive and one's a negative. And when you do the math, it becomes zero. Okay. And so we want to make these. So we want to line up the letters with each other, just like I did here, like line up the X's with the X's. And so we're going to line them up, and then we're going to see if we can make zero pairs out of them. All right, so look, number one, I'm going to do it. First thing is I want to line up my numbers, and we always put the alphabetical order. So I'm going to say 4x plus y equals 10. The other one is 6x minus y equals 20. All right, so the first thing I want to do is I want to see if there's a zero pair. So I want to look to see if there are two things that are exactly the same, terms, is what these are called, two terms that are exactly the same, except one's a plus, one's a minus. Well, if these two, one's a 4 and x and one's a 6x, so they're not the same. But this one's plus y, minus y, so that is a zero pair. So we can just mark those out, all right? And then we're just going to add straight down, or actually look at their signs. So there's a positive, and that's a positive, so that's 10x. That cancels out. Bring down our equal sign. 10 plus 20 is 30. We're going to divide both sides by 10 to find out what x is going to be. And you can actually figure it in your head. What do I multiply to 10 to get 30? You should say 3. So x equals 3. All right, so now what I'm going to do is I'm going to take this 3 and I'm going to plug it into one of these equations. And I'm going to pick this one. It doesn't matter which one I pick. I'm just going to pick that one. So where there's x, I'm going to put the 3. So 4 times 3 is 12 plus y equals 10. And you can see, what do I add to 10 or 12 to make it 10? Well, we're going to subtract 12 to both sides. And you're going to see y is going to be -2. So my x value and my y value is in order pair. So I'm going to have 3 and -2. So don't forget, this is where my line crosses, where my two lines intersect at. Okay, so that's how you do it. All right, so that's one. All right, number two, we have 5x minus y equals 22. I'm going to go ahead and line them up, though you can see the y's first, but I'm going to put this 4y under this y and this 5x under that one. All right. So if you look at this, I do have two terms that are exactly the same, but they're both positive. This one's 1y, the other's 4y. And we don't care if these are the same or not. We're only interested in the letters. So I have two ways. I can try to make this a zero pair, or I can make this a zero pair. Since these numbers are already the same, the only thing I do is need to change the sign. And I can change the sign to change the top one or the bottom. It doesn't matter. I like changing the bottom. And the reason why I like doing the bottom is because that's what I'm used to seeing. All right, so I'm going to put a -1 and multiply it to everything here. So the first one is going to be exactly the same. So I'm going to leave it in the same color just so you can see that nothing changed. All right. Now this one, however, I'm multiplying a negative to the 5. So really it becomes -5x. This -1 gets multiplied to 4. That makes it a -4y. And this -1 gets multiplied to that, makes it a +63. I forgot my equal sign, didn't I? +63. All right. -5 plus 5 minus 5 is 0. A -1y. Remember that anytime you see a letter, there's a 1 in front of it. So we'll just put imaginary 1 there. There's a 1. So -1 and -4, that's a -5y. And 22 plus 63 is 85. All right, so now I'm going to divide both sides by -5. And then y equals a -17. So that's my first one. Now, again, I'm going to take this and I'll plug it up to one of these. It doesn't matter. And I'll pick the first one just so we can kind of see it. All right, so I picked that one and we're going to plug in y. Now watch this because this does happen. My y is a negative 17 and I have a subtract already there. So now I've got to subtract and my y is negative 17. So that's my y. All right, so two negatives make a positive. Subtract 17 to both sides. And if I divide both sides by 5, it looks like x is going to equal 1. So my ordered pair is 1 and negative 17. That's where it's going to intersect at. All right, my third problem. All right, so I'm going to go ahead and write it down. So my third problem is 5x plus 7y equals 18.9. And I'm going to line up my letters. This one has decimals. All right, now this one is a little bit different. This one, we have no numbers the same, and so it's going to be a little bit more interesting. We may have to play with both of them. Now, I know some of you might catch on that if you multiply 2 and 2.5, you'll get 5. Like think about it, if you had $2.50 and you multiply by 2, you'd make $5. And you can multiply the bottom by 2.5. Okay, but also remember that this is a positive and this is a positive. So you'd actually have to multiply everything by negative 2.5. I'm not going to do it that way. I'm going to take a problem. I'm going to actually show you what happens just in case you can't do that. So I'm going to take the y's and I see that I can make both of these guys into 21. I can multiply this 3 into 7 and 7 into 3. And I can do 10 here. I can say 2 and 5 and 5 and 2. All right, so I'm going to do this. So here we go. I'm going to multiply the top by 3 and I'll multiply the bottom by 7. Now I chose the y's because one's a positive, one's a negative, and I don't have to multiply either one of these by -3 or a -7. If I did the x's, then I would have to multiply by -5 or -2. So here we go. I'm just going to distribute. So 3 times 5 is 15x. 3 times 7 is 21y. 3 times 18.9, and I'm going to get my calculator just so I don't make a mistake here. And I'm going to say 18.9 times 3. And that gives me 56.7. All right, let's make this x a little bit prettier. All right, at the bottom, 2 times 7 is 14x. 2 times -3 is a -21y. And 7 times a negative, that's going to equal a -56.7. All right, so I'm going to go straight down. 15 and 14 is 29x. This becomes a 0 pair. And if you look here, 56.7 minus 56.7, that equals 0. And I have to put a 0 there because we have an equal sign. I got to have something over here. Now this makes this pretty easy. 29, divide both sides by 29, and x equals 0. So I know x is 0. So now I pick either one of these, and I'm going to pick the bottom one this time. So we'll say 2x minus 3y equals a -8.1. X is going to be 0, so it'll be 2 times 0. All right, now this becomes 0, so now I have 3y equals a -8.1. All right, I'm going to divide both sides by -3. My y is going to equal, so we take a calculator. And we're going to say 8.1. And we're going to divide it by 3. And we get 2.7. So my answer here is going to be for my x and my y is going to be 0 and 2.7. That's where the lines will intersect. All right, so let's try a couple more. We got 2 more to do. All right, and we're really going to be doing these 2 right here, the special case ones. So I'm going to go ahead and write these down real quick. This is number 4. I'm going to do the other one right here, Just go ahead and put it down so that way we don't have to write. All right, so we have the last two problems here. Again, we're going to try to make a zero pair. All right, so let's see. We don't have a zero pair for the X's or the Y's, and so we can make them. So let's go ahead. These are both positive. These are both negative. So we are going to have to multiply a negative number. So let's take the top and multiply a -2 to it. All right, so multiply -2 to X. That's going to be a -2X. -2 times a -2 gives me a +4Y. And -2 times 3 is going to be -6. All right, the bottom we're not going to touch because it's already a 2. So we're just going to leave it the same. So I'll leave it the same color. And there we go. Now watch, -2X and a +2X, that makes a zero pair. A -4 and a +4 makes a zero pair. Now there's an equal sign here. So both of these are negative or zero. We have to put a 0 over here. -6 and +6 is 0. So this is one of those special cases we talked about in the substitution method. Does 0 equal 0? Well, the answer should be yes, it does. They're the same number. Because they're the same number, we're going to have the same line. They're just going to be one on top of the other. This is called an infinite set. We call it in our classroom all real numbers. Remember, it's the one with the double bar, R looking thing. All right, so that's how you do it. And that's our answer. Our answer would be all real numbers. Now let's look at this one. So I will multiply the same big, this one's a negative, that's a positive, negative. So let's just try to multiply by 2 this time. And we're gonna multiply this whole thing by 2. So 2 times a -X is a -2X. 2 times 2 is 4Y. 2 times 3 is 6. The bottom, I'm going to keep the same. And look again, -2X and positive, that's a zero pair. 4 and -4, it's a zero pair. So on this side, we have to have 0. Oh, I put 2 here. This is supposed to be a 3 because I didn't distribute. 6 plus 3 is 9. Does 0, no, all the variables are gone. So does 0 equal 9? The answer is no. And so we mean no solution. So when you say no, then you mean no solutions. That means the lines are parallel. It's a little circle with a line through it. It means empty set, which that's something that you'll use later. All right, and this is how you do the elimination method. Just find a zero pair. And once you find a zero pair, then you have found your solution.